All right, so let's talk a little bit about, so far in this 9 weeks, we've had about 6 assignments that have been graded, and about half the class is missing at least 2 of those assignments. So I would encourage you to check Infinite Campus regularly this 9 weeks. It feels like we started the last 9 weeks really strong, and then it feels like some of us have fallen off and are not doing our homework, not doing what we're supposed to do. Wednesday's lunch tutoring this week will be moved to Tuesday. I will be out at a training on Wednesday and Thursday. So the Wednesday lunch tutoring is going to be moved to Tuesday, and Mr. Millwood should still do the Thursday lunch tutoring as scheduled. So let's look at homework 9 so we can talk about some expectations and some things that we're missing a lot still on homework. Homework is all just a review of things that we've already done this year. So if you are not making a passing grade on homework, you should be concerned about that. Homework should not be something that you are still missing problems like 1 through 3, because we've been doing those for about 6 weeks now. And we've shown you many ways to do that. So if you're still missing those, you're just not trying hard enough. You're not using your notes, or you're not coming to tutoring. It is not okay to still be missing problems like 1 through 3. That was not even new material this year. So we need to be a little bit more reflective of the mistakes we're making. And homework is a grade, and it's just like a quiz grade or a test grade. It's just as important as any other grade. And you have 4 days to work on it every single week. It should be the one assignment that you turn in that you know you're going to get a good grade on. If you're one of those people that's not turning it in, or you're making a failing grade on it, you need to change what you're doing, because it's a problem. So 1 through 3, you can use a calculator. 4 and 5 are fraction problems that you have to be able to do without a calculator, which means if I only see an answer circled and no work, even if that answer is right, the problem is wrong. You could have scratch paper and it could be stapled to it. But if you just have an answer, then my guess is that you used a calculator to solve it, and it is going to be wrong. Tuesday section, no calculators. I should see on problems like 15, or like number 3, I should see where you've changed that. Subtracting a negative is the same thing as what? Adding a positive. I should see those changes made. You cannot use a calculator. So this is a subtraction problem. Addition. This will change to an addition problem. What kind of problem is number 4? Division. What kind of problem is number 5? It's a multiplication problem. People are having a hard time, and they're thinking that because that negative is there, that's a subtraction problem. When you have a number right in front of the parentheses without an add or subtract, then that's a multiplication problem. And that is an addition problem. 7, A and B. You need to use this chart over here to answer these questions. On these, I should still see where you've done some work, either down here or on scratch paper. All of this is a no calculator section. All right, so far on the front, the only thing you use a calculator on is 1 through 3. Okay, on the back, you can use a calculator. You have to show the substitution. If you do not show the substitution, you just have an answer right there, it is wrong. You must show the substitution. All right. 1, write an expression in simplest form for the perimeter of this figure. What does that want you to do? We've been doing these for a while now. You're just adding, to find the perimeter, you're adding all the sides. And then you have some that have the variable x and some that have the variable y. So what does that mean? You're combining like terms. Thank you. 2, the table shows the breakdown of points scored in last week's baseball game. So this doesn't really look like what points would look like, but you're going to do the same thing as if this was a 5 and this was a 6 and this was an 8. You're just going to add the appropriate section. So write a linear expression in simplest form to represent the total field goal points scored in the first 2 quarters. So here's the first quarter and here's the second quarter. So to find the total, what do? Total means to add. So you would add these together and combine like terms. Write a linear expression in simplest form to represent the total points scored in the entire game. So that's the first quarter, the second quarter, the third quarter, the fourth quarter. Do we need to add the free throw? Yes, you need to add that too. You have to add up all of these for B and combine your like terms. Any questions about anything? This homework, in all honesty, should not take you very long at all. It is not very difficult. Questions? Okay, let's put that to the side. All right, warm up 34. Number 1, a marathon runner runs 10.5 miles in 2 hours. What is her rate? Write an expression to represent the problem. So rate is what kind of problem? Anybody remember? Yes. It is a division problem. So if we want to know her rate, we're talking about miles per hour. So that means miles needs to be on the top and the hour needs to be on the bottom. So 10.5 miles in 2 hours equals how many miles in 1 hour? I can kind of reason my way through that. Can you kind of reason your way through that? Anybody have an idea of what it is before we do the work? What is it? 5 1/4, right? 5 1/4, because we're just dividing it by 2. But to solve the problem, 10.5 divided by 2/1. 2 times 10 is 20 plus 1 is 21. 21/2 times 1/2. Right? To divide, we keep, change, and flip. And we get 21/4. Everybody know how I got 21/4? And then, did you say no, Dominic? So 21 times 1 is 21, and 2 times 2 is 4. Can we leave it like this? No. What do? We divide. 21 divided by 4. It goes 5 times. 20. You get a 1. Now, I can either leave it like this and get a fraction, or I can annex a 0 here and then get a decimal. What kind of answer do you think I want? If it's a fraction problem, your answer should be a fraction. So your answer is 5 1/4 miles per hour. At East Middle School, 28% of the students are in the band. If there are 168 students in the band, excuse me, how many students go to East Middle School? So we're doing like we did on 33. We're doing that part over whole, because that's what a fraction is. Part over whole equals the percent over 100. So this is a part and this is a whole. So the percent is also a part and the whole is 100%. These two things are equal. So whatever the whole is 100%. Whatever the part is that's the percent. So let's see if we can figure out what we need to put in where. So whole, what are we talking about? We're talking about the students in the whole school. And the part, what's the part we're talking about? Going back to the problem. Students in the band. So these should be band students up here. And this should be the whole school over here. So it helps me start figuring out where things need to go. So these are the numbers I have. I have 28% and 168. Where do they go in my percent proportion over here? Well, the 28 should be easy. Where does it go? Above the 100. There are 28% of the students in the band. The 168, is that the part in the band or is that the whole school? That's the part in the band. So if this is the band, this has to be the band, 168. Now I can use that. 168 kids is 28%. Those two things are equal. So I need to find out how many's in the whole school, or what's 100%. So cross multiply 100 times 168, 16,800. And over here, 16,800. How do I solve this? So it's this times this would equal that. But if I can't figure out what to do, then you need to divide. Which number comes first? 16,800, right? How many kids are in the whole school? 600. It should be a bigger number, right? There are 600 students that go to, I just abbreviated East Middle School. All right, everybody good? Anybody still copying? Okay. All right, let's look at these one-step equations. This should just be a quick review. We've even done some of these earlier this year. But we're going to start two-step equations tomorrow. So we need to do a quick review of one-step equations. And we need to practice some of those with rational numbers today. So let's look at example 1. Example 1 is an example of an addition one-step equation. So if the original problem is x plus 12 equals 26, to solve that, the first thing you do is undo the addition or subtraction first. So we want the variable by itself. That means we need to get rid of this positive 12. What's the opposite of positive 12? Negative 12. So let's do that here. X plus 12 equals 26. Subtract 12 from both sides because remember, an equation is like a balance. I know some of us like to draw this little line right there. We're left with X. Positive 12 and negative 12 are a zero pair. They go away. Bring your equal sign straight down. And 26 minus 12 is 14. So you're left with the equation X equals 14. Do you remember how to do that? We are looking to see that you have solved it just like this. It's going to help you if you know how to write it the correct way when you go to do two-step equations. All right, so example 2 is a subtraction problem. N minus 23 is 46. So you undo the addition or subtraction first. So we want the N by itself. That means we need to get rid of this negative 23 or subtract 23. What's the opposite of subtracting 23? Add 23 to both sides. So N minus 23 equals 46. So add 23. You are left with N equals 69 when you add. So here's your answer. All right, everybody good with that? All right, Savannah, I'll let you copy mine in just a minute. Let's go on to example 3. Did everybody get that one? Okay. Example 3, this is a multiplication problem. The original problem is 3 times x equals 18. So here you're going to undo the multiplication or division first. So 3 times x, what's the opposite of 3 times x? Divide. It needs to look like this. Lots of people want to then put a big line here. That's not it. It's 3x divided by 3 and 18 divided by 3. Well, 3 divided by 3 leaves me with a 1x, and 18 divided by 3 leaves me a 6. So x equals 6. And if I use substitution, I could check that. 3 times 6 is 18. Questions? Doesn't it seem so much easier this year than it was last year? All right, here we go. 4. This is a division example. The original problem is x divided by 4 equals 6. This one's the one that people have the most trouble showing. So, what is the opposite of dividing by 4? Multiplying by 4. So, it's going to look like this. X divided by 4 equals 6. So, I am going to, instead of dividing x by 4, now I'm going to multiply by 4. So, I put it up there next to the x. And then I put the 4 over here. Doesn't it look similar to this problem right here? Except now I've got different work to do on this side. So again, 4 divided by 4 leaves me with an x. And 6 times 4 is 24. And I could check that. 24 divided by 4 is 6. So these problems should both on this side look the same. All right, everybody okay with those? Okay, so let's cut them out and put them in our journal, and then we're going to try some practice problems. So if it was me, I would not cut out each individual square. I kind of cut mine out to look like this. So just be quick. Cut them both out, and then we'll talk about what page they go on. If you don't have scissors in your pouch, I bought some new ones, so they're over in the drawer. So there's your table of contents. Today's the 21st, October 21st. They're called one-step equations, and they're going to go on 34 through 37. 34 through 37. So page 1 is going to go on 35, or examples 1 and 2 are going to go on 35. 3 and 4 are going to go on 37. 34 and 36 are going to be blank. So there's 34 and 35. 1 and 2 are going to go right there. Yes, in that drawer. All right, everybody good with that? So on the right side. All right, so these are a little bit more difficult because we've got some fractions and some decimals. Still the same thing, so let's look at number 1. 3 4/10 times A equals 57 8/10. So we want the A by itself. So the opposite of multiplying by 3.4 is dividing. It needs to look just like this. Divide by 3.4. .4 divided by 3.4 leaves you with a 1, so we don't put the coefficient 1 with it. It just leaves us with 1A. And then on your calculator, you can solve 57.8 divided by 3.4. And you get 17. So A equals 17. Check your solution. That means I do 17 times 3.4, and I should get 57.8. That's checking our solution. Everybody okay with that? Okay. 2. Why does this one look different? It has a negative. It also looks different for another reason. It seems like it's backwards. So should we change the order? No, don't ever change the order. So let's read this. So this problem says -2 equals 8/10 times n. So here we're not going to divide. Lots of people are tempted to divide by the -2. Well, if we divide by that, that's not going to leave what we need over here. We want the n by itself. So the opposite of multiplying by 0.8 is divide. You've got to do that on both sides. Then start this way. 8/10 n divided by 8/10 leaves me with an n equals -2 divided by 8/10. -2. Use your negatives, divided by 8/10. And you are left with -2.5. If you swapped those sides, if it said n equals -2.5, it would be wrong. Do not switch the sides. It doesn't have to say n equals -2.5. This just says what's on each side of the equal sign are equal to each other. Everybody okay with that? All right, 3. 5/6 k equals -20. So what's happening here between the 5/6 and the k? What's the operation happening there? That's division happening there? But they're right next to each other. It's not up in the numerator and the denominator. That's multiplication that's happening right there. That's 5/6 times k. What is the opposite of multiplying by 5/6? Divide by 5/6. Divide by 5/6. Now this looks different because those are complex fractions. That's okay. 5/6 divided by 5/6 goes away. You're left with k equals, and now -20 divided by 5/6. You know how to do that on your calculator. -20 divided by 5/6. Everybody okay with how to put that fraction in? And you get -24. All right, number 4. What do I need to do on number 4? Anybody tell me? Nobody knows what to do on number 4? Mackenzie? Divide. What am I divide by? Yep. 9/10. Divide both sides by 9/10. Should look like this. Should look like this. Start over here with the variable. 9/10 divided by 9/10 leaves me with an A. A equals. And now do 12 divided by 9/10. And you get, so we write that as 13.3. The repeating bar goes over the 1/3. How is it 1.3?
You said 1/3.
Oh. It's 1/3 after the decimal. I meant you only write, when it's repeating, you only write one of those 3's after the decimal. Sorry, I wasn't clear. So then you put your line over this 3. Everybody okay with that? All right, look at number 5. Somebody tell me what to do. Autumn, what do you think? What are we going to divide by? We're going to divide both sides by 3/4 because this is multiplying. C and 3/4 is multiplying, so the opposite is divide. Oh, I don't want to write that there. Hold on. All right, so 3/4 divided by 3/4 leaves me with a C, and C equals -12 divided by 3/4. -12 divided by 3/4. And you get -16. All right. Let's skip down to number 8. Somebody tell me what we want to do on number 8. Divide. What do we want to divide by? Divide both sides by 3/7 because this is multiplying B times 3/7. So the opposite is dividing by 3/7. You all are lucky because when about 4 years ago, we did not use calculators on this. So you had to remember how to do all of the math. You had to remember the positives and negatives. Okay, so now what? -15 divided by 3/4. -15 divided by, not 3/4, I'm sorry, 3/7. -35. And notice how we didn't change the sides. We said the B comes straight down. So -35 equals B. Let's go to 10. 7/3 x equals 2/3. What do we want to do? What do you think, Summer? Okay. So is that going to get the x by itself if we divide both sides by 2/3? Remember, to get this x by itself, we have to undo the number right next to it. So we need to divide by 7/3, right? Good try. 7/3 divided by 7/3 leaves us with an x equals, and then now in your calculator, 2/3 divided by 7/3. 2/3 divided by 7/3. Is that right? Oh no. 2/3 divided by 7/3. 2/7. X equals 2/7. Try 11 on your own real quick. Try 11 on your own. Who can tell me what I do on number 11? Savannah? Divide both sides by 3/4, right? Because we want the h by itself. We want the variable by itself, so we've got to get rid of that. So divide both sides by 3/4. That leaves us with an h over here equals, and then 11/12 divided by 3/4. And that leaves us with 1 2/9. 1 2/9. That's how you write that. That's a 1 space 2/9. Everybody okay with that? All right, let's try number 13. Anybody tell me what we're going to do on 13? Mackenzie, what do you think? We would multiply, right? This is saying m divided by 26. So the inverse or opposite of dividing by 26 is multiplying. So I'm going to put 26 up there and 26 over here. 26 divided by 26 leaves me with an n equals, and half of 26 is 13, and so it's negative 13. You can check it on your calculator. Negative 1/2 times 26 is negative 13. Try number 14. Try 14. Breezing your way through it. Somebody tell me what we need to do. Andy? Multiply. What am I multiplying by? Andy, what am I multiplying by? Multiply both sides by 5. And so that leaves us with an n on this side. Make sure you didn't switch your sides. And 5 times 0.6. 3. 5 times, you get 3. Everybody good with that? All right, so do you get the idea? All right, so try a few more of them on your own. Then check in with us.